So hi everyone, Payor, Director of MedTech at Microsoft, focused on remote monitoring and some of the use cases that come with it. So just wanted to dive into the solutions that we have. So hopefully everyone can see my screen. So then, as mentioned, Payor, and just sharing our platform and what we have to offer for remote monitoring and IoT. So in this case, you've probably gone through some of the journey of the training so far, and there's more to come in the future. So for this, we want to focus on the agenda around the different aspects of it. So, why or what we consider for remote monitoring, what's the interoperability, how does this integrate and empower the health workloads as well? And then also triggering of events. So one of the big things as part of the IoT data or remote monitoring is what do you do with that data? So we'll dive into some of those aspects of it as well. And then what are the partner opportunities and things like that that also exist as part of it? And then how do you normalize the data for the healthcare within the IoT streams? So what we want you to take away is our different services that we have. So we have a currently generally available service for Azure API for FHIR. And then we have a public preview of our healthcare APIs today, and then all the different associated components with that. So diving into this, let's talk about IoT and remote monitoring. So our team core focuses on the center part of this cloud for healthcare journey and wheel, and we look at unstructured data, imaging data, structured data. How do you use that for secondary usage, as well as being able to visualize that data, and all that is delivered with an enterprise scale, I promise. So the big things remote monitoring unlocks for our partners and customers is the ability to provide virtual care, also provide asynchronous care. There's a lot of law changes that are happening to actually allow for asynchronous care or care without needing a visit. Then also, how's that data also used within the decentralized clinical trial, and how do the components of virtual care help with the collection of data during this journey? So then I want to kind of just show a quick example of what decentralized clinical trial journey looks like. So, when we look at the aspect of it, the different design considerations are from the trial design, the initiation, all the way to reporting and closeout. So, we kind of look at the whole journey of the trials. And then the different personas that are affected by it. So, is it a pharma sponsor? Is it a CRO? Is it a clinical trial investigator? You have some clinical trial patients as well. So what are the different personas, and what is the technology needed for Microsoft to support that? So then the first question is bringing data into the platform. So, this starts to talk about how we look at the different verticals within remote monitoring. So we looked at the cms.gov, and these are the top 10 conditions, where the most amount of payments were created. So we kind of look at a similar way from a use case perspective is how do we make sure that we have a platform that can support high blood pressure, high cholesterol, and go down the list for a lot of those capabilities. So when you step back and look at all those different capabilities, they all come down to a similar set of vitals that are needed to manage those conditions. So, you need some activity tracking, the vitals, heart rate, weight, and different aspects of it. And then a typical, set of scenarios that are needed as part of it. So you have the reduction of resting heart rate, for example, weight management, as well as improving the engagement and the outcome. So we kind of look at a couple scenarios, and then based on the data that's coming in, how you can leverage events to help fulfill that. So just kind of, showcasing the different parts of the vital. So when we look at our MedTech service or IoT connector, we actually spent some time at looking at high velocity data, things like EKGs and heart rate. You have low velocity data, which is like blood glucose monitors or weight sensors and others. And then you have aggregate data like activities, steps, and others. So we look at a variety of different types of data and the data profiling, and we make sure that that is able to be persisted within the platform into the FHIR store. So now walking through it, so you have a couple options, from our service perspective. So either you can use our current GA service, which is on the left side here, where you can use our Azure API for FHIR, as well as you can use an open source version of the IoT connector and the open source version of MedTech, as probably discussed in the earlier call. And then you have the ability to use a lot of the platform capabilities. Or you can look at our previous service of what we are providing, which is the IoT connector, the FHIR server, the DICOM, all within the workspace boundary to maintain HIPAA and high trust, as part of it. And we have this as a managed service for you as a PaaS service. So, during this journey, what we're looking at is how do you take the real world data, have real world evidence, and then create actions from that. So in this case, we have a payer who's looking at, helping provide better care for, our patient here. So this is where, a payer organization may want to look at the different risks, collect the data, and then based on that, provide the appropriate care. And then all Tara as a patient needs to do is actually make sure that the appropriate consent is granted to the payer organization to help, collect that data and, help determine patterns within that. So the couple of use cases we'll walk through in a couple of minutes is, once the data is brought to the platform, how do you create events and alerts from the platform to either prevent readmission or minimize that? And then also from another use case of how do you actually do patient-reported outcomes? So how do you actually have frequent questions that you can ask the patient to understand what's happening with them as well? So one of the first things I want to dive into is IoT data comes in all shapes and sizes, and there's not much standard out there. So from a platform capability, what we have done is we've given you the ability to bring data from any type of JSON format here. So as long as the device can give you the data in a JSON format, you can bring it into the platform and normalize it into a structure that you like. So this is where Google might say heart rate, but Apple Healthcare may say HR, and something else might have different appropriate tags on it. So that you can normalize it into a preferred name that you want as part of the platform. Then also the ability to actually bring in data which devices that emit different types of data. So in this case, a blood pressure device will actually emit a couple of different data points. You may want to store that separately within the platform, so you have the ability to structure that appropriately here. Now, within the normalization pipeline, you have the ability to add calculator functions here. So if there's some units of measures conversions needed to go from, Celsius to Fahrenheit or pounds to kilograms and others, you have the ability to do that at the normalization step. Once it's converted into a standard structure across the various devices of the device pool that's coming in, then it goes into the next step, which is called the FHIR observation. So this is where you can add the appropriate additional items as part of it. So you can actually have the appropriate units in here. So add the units of measures, add the ICD-10 codes, the low-end codes, the SNOMED codes. You can actually add all of that capability here, so that when the receiver application is looking at it, they have the ability to segment that by the device type and what they bring to the platform. So just kind of giving you a holistic perspective to what the remote monitoring platform has to offer. So what we have is the ability to bring in the data from the different ecosystems. Either those devices, if they're network enabled, can be connected directly to the platform, or if they're not network enabled, they can go through one of the aggregate open source structures that we've provided, like the Apple HealthKit, Google Fit, Fitbit, and other things. And then you can bring that data through that platform into our service. Once it's in the service, then you have the ability to use that across a variety of different Microsoft services out there. So if you want to use things like Azure Data Factory, Event Grid, Event Hub, you have the ability to use that. If you want to create smart and FHIR apps on top of it, you can definitely do that as well. Any of the Power BI reports, or if you want to trigger things inside Teams, you're welcome to do that as well. And of course, since it's all on Azure, you have the ability to use all the other tools, which are Databricks, Synapse, and others for analytical purposes as well. So just a simplistic architecture of what that solution looks like, what we just were walking through is you have the different devices that can go through the aggregator. So you have the HealthKit aggregator that you can bring that platform through. So any device that connects to the Apple HealthKit can connect into that as well. And then that's brought through into our service through the IoT connector into the storage layer of the API FHIR. Couple patterns exist here is if it's a Apple HealthKit, then it's a device to cloud integration. If it's a Google Fit or Fitbit, then it's a cloud to cloud integration. So you have the ability to run some of these functions directly and access that data with the appropriate consent and provided. Once it's stored in the platform, then you can run machine learning models and others to be able to do some analytics and predictive analytics on the use case, and then visualize that data either through the Smart and FHIR app platform or your Power Apps or Power BI ecosystem. So then, just diving a little bit deeper into the cardiac patient monitoring alerts here is, a few personas that were used is you have the data architect who is who's going to decide basically what type of records are needed as part of from the FHIR structure and what needs to be stored in there, appropriately map things into the FHIR structure. The specific decisions to make there is within the observation itself, you have the ability to store things in sample data or values ecosystem. So how should that data be stored within that segment of it? Then, the analytics, the director of analytics can look at it saying, what are the different machine learning models used to actually validate some of those things and to create the right level of filter for alerts. This is a common problem where a lot of alert fatigue happens. So this is just making sure that we have the right models outputting the right set of triggers as part of it. And this is where the chief clinical officer comes into saying is making sure that the filters are appropriate and validated, with the help of a physician in most cases here. And then, as the actual persona, so that was to build the application, but as in terms of actually running the application, you typically have two different personas here. One is the member counselor who's providing the care to the patient, and then you have the patient themselves who are receiving the care. So in this case, similar architecture but simplified. We see Apple HealthKit being used in some of these cases. So again, showing something very, very similar, but the only difference is some of the connections are through a Power BI gateway service if someone has enabled privately enabled FHIR server. Then now let's talk about a little bit more on the patient-reported outcomes. So as far as patient-reported outcomes, one of the things that you probably want to do as the counselor is be able to ask frequent questions to the patients. And let those answers determine the next steps of that journey in terms of care. So in this case, we see patient-reported outcomes being used for a variety of different scenarios, like a post-care monitoring, where if someone had a surgery, they went back and, you may want to collect the pain level, for example. If the pain level is decreasing, it's probably on a healthy path. If the pain level is increasing, you may want to intervene and do other things with that. So we see some of those scenarios there. Then the other one is compliance. And this compliance is more for compliance of adherence of medication and other things. So that you may want to actually look at the patient actually appropriately having the right medication on hand and taking it. So in some cases, we see those scenarios as well. And then, of course, clinical research. As part of the research, you may have a bunch of questions that are needed to be answered by the patient themselves. So what that looks like is Apple has released something called a ResearchKit as part of their service. So what we have done is we have done a ResearchKit on FHIR integration, which is in our open source, where it's pretty much a UX layer provided by Apple ResearchKit. So as part of when you actually ask those questions, it shows up in the iPhone with the appropriate interface that's designed by Apple. We just leverage that as for some of those things. So it's just a simple walkthrough of being presented a bunch of questions. Then those questions show up, and you can actually have a response to those questions. And then underneath the hood, what's happening is a FHIR questionnaire is created, a task is assigned to the patient, and when the patient fills out their question, then a questionnaire response is created within the platform, and then a task is set to complete. So a couple things happen underneath on the FHIR protocol side. Then kind of just showing you some of the real world use cases here is what you may have is a lot of the low frequency or high frequency data coming from your various devices going into the platform. Based on certain triggers, you may want to initiate patient-reported outcomes or have some follow-up questions back to the patient. And then based on those responses back, you may create additional tasks underneath it. So it just kind of shows you the power of actually having triggers and alerting capability within that. So just, this is a different way of kind of showcasing the journey of actually creating an application like this. So as a partner, you could use a lot of the open SDKs we have and the extensions we have built on top of others here, which can end up creating a end patient application that your customers can use. That data can be coupled with a lot of the IoT data that comes into the platform, gets stored and persisted into our FHIR server. And then you have the member council looking at their interfaces on top of it and being able to actually, respond appropriately. So just an example of what the ResearchKit integration looks like. So it doesn't change the architecture much. It's just adding the SDK for the ResearchKit on FHIR extensions we created within your application enables you to do that. And this is just kind of showcasing that you could use other aspects of it as well. So, and if you actually want to initiate a phone call post this, you have some Teams integration as well. Then one of the things that we want to kind of showcase is there is a lot of concern that's happening in the world about wearable data and a lot of the leaks that are happening with it, which is why we spend a lot of time actually ensuring that the platform we provide is actually HIPAA and high trust compliant, has a lot of the security measures and controls in it so that you don't end up in news like this. So we provide a lot of those levers, but we do want to kind of highlight is this is something that is that's something we partner on to make sure that we provide a platform that gives you all the compliance within the different regions. So just an example of some of the high level ones we want to highlight here is from a compliance perspective, we look at making sure we are ISO certified, we have the appropriate HIPAA and high trust controls in place. We do look at regional capabilities as well. And if you want to read more about some of these, it's in the Azure compliance link at the bottom. A couple other things I want to highlight before I start taking some questions is we've done some update to our documentation to make it easy to consume. So in this case, there's a couple examples of what our documentation says. If you're looking to do machine learning interfaces, then we share some suggestions of architecture, suggestions of components, and the use of those components as well. So that's on the left side. And on the right side, one of the popular use cases we see is based on certain measurements, you may want to invoke a Teams conversation. That could be a text conversation, it could be a voice conversation. So it showcases the ability to do some of those things here. So I'm going to this is kind of showcasing hopefully the key learnings that get provided as part of this platform. Is you can probably see the ability to take the IoT data from the different devices, normalize that, store that in FHIR with the appropriate compliance in place. Then also looking at the ingestion of the different services, different components as part of it from the different research kits, and then remotely monitor it for your patient-reported outcomes. And a couple links, that can just help you get started. So then I see a question in the chat, a couple questions in the chat. So one of the questions is the address of the volume of the data that comes into the platform. Our services, we usually channel a lot of things through either the IoT hub or central. So this is where a lot of the IoT hub and central are the front where it scales into the platform, and then the way our services are built on the back end is actually in scale. You shouldn't have a lot of the scaling concerns, but we can definitely take a look at that. So for bad reading, with the calculated functions we actually have the ability for you to actually even put in some conditions in there. So if you want to actually do some conditions and of saying as if the data is outside of a certain range and you may want to discard that, you can have that as a calculated function as well within the platform. So that's one way of addressing bad readings. That you can actually manage that as well. So we do provide you with the controls to do that. That's another question for calculation transformations. I can definitely share one of the links. It's actually a sublink within the technical documentation for IoT for calculate functions, but we do provide a variety of patterns for what that looks like. Let's see if I can actually pull that up live. So the question is what type of calculations that we support as part of it. So just want to bring the docs page up. This is where you have the custom functions ability. So you have the ability to actually do different exception handlings as well as some of the calculate functions if you want to do mathematical operations or other things. We give you a variety of tools, to do some of those things. As part of your framework here. So, and then one of the top ones we saw was a conversion of Unix timestamp, and this was specifically added for FedBed. So we do see a number of those kind of examples for calculate functions in the normalization pipeline. So it's just a JSON template that you can add with the appropriate expressions. And given the expression, it will actually output the respective values for you. So the use of it is just simply basically adding expressions as part of your template. Is the patient ID included in the IoT data? So typically, the patient ID is not included in part of the IoT data. What is included is the device ID. So the way everything is structured underneath the hood is the observation is connected to a device, and a device is connected to a patient. So that's your referential key, and most devices actually give you the device ID, and appropriately internally, you can run our IoT connector in either create mode or lookup mode. And the two differences between the create mode and update mode is, do you want to create the patient as part of a new payload, or in the lookup mode, which means the patient's already created and you just want to look up the patient based on the device ID. And the reason why we have that decision factor is to actually excuse me, is to allow for two different scenarios: pre-provisioned devices or real-time provisioning of new devices off the shelf. So hopefully that helps answer some of the questions that came in the session. So there is the way we've built the so another question came in is, what if the device is not supported by default? So the way we've built the platform underneath the hood is it is not device specific. It's a JSON payload. So in a lot of cases, we just take the JSON data that comes from those endpoints and we convert that over. So you can define your own template as you need. It's not restricted to any specific device. In fact, it's actually made in a generic manner so that you can onboard any JSON data to convert it over. So in some rare legacy devices, we are seeing CSVs or we are seeing XMLs, those are conversions that you can just run before sending that to the pipeline. Cool. So I think that addresses all the questions, Dana.
As always, Raja, thank you so much for joining us. And great questions from all of you partners, Microsoft team members who are on with us today.